Hi everyone, today we're talking about particle motion, which is just an application of all the derivative test stuff we've been doing lately. So first, they give us a function that models our particle's position. And for part A, they ask us to find the velocity function and then evaluate it 1 second. All right, so all we gotta do is take the derivative. So hopefully you remember that the derivative of position is velocity. So if we take the velocity, that'd be 6t squared minus 14t plus 4. So that's my velocity equation. Now they want me to evaluate at 1. And we haven't done a lot of practice with this in our calculators, so I'm going to show you. If we go to our calculator, I already have my original equation in there. And so if you could want to find a derivative from your original equation, you can go to second window, that F2 menu, and go to the third option down. All right, so this is my derivative notation, so I'm taking it with respect to x. I want to take the derivative of my y1 function evaluated at x equals 1. And you can only do this when you're evaluating at a point. And we get negative 4. Right, so we get negative 4, and we're in meters per second. Okay, for part B, it asks me when the particle's at rest and when it's moving right. Okay, so I'll get rid of this. It's going to be at rest when my velocity equals 0, because it means the velocity is not moving. It's moving right when the velocity is positive. Okay, and it would be moving left when the velocity is negative. Okay, so first we need to do the first derivative test. So I need to figure out my critical numbers. So I'm going to take my first derivative and set it equal to 0. Okay, and so I'm going to factor a 2 out. So I have 3t squared minus 7t plus 2. So this factors to negative 2 minus 1. Okay, so that means that t is 1/3 and 2. So here are my two critical points. And so if I make a sign chart with 1/3 and 2, right, so if I plug in any number smaller than 1/3, here greater than or equal to 0, so don't be plugging any negative numbers in. So if we plug in 0, for instance, we'll get a positive. Okay, if I plug in a number between these, like 1, I'll get a negative. And if I plug a real big number in, I'll get a positive. Okay, so it's asking when it's at rest, so I know that the particle is at rest at t equals 1/3 and 2, because v of t equals 0 at those points. Or you could say like v of 1/3 equals 0 and v of 2 equals 0. That would be good justification there. Okay, I know it's moving right on the intervals 0 to 1/3 and 2 to infinity. I guess it's always moving. Okay, 2 to infinity, and my justification would be because v is greater than 0 at those intervals. Okay, let's move on. Okay, then it asked me to find the acceleration at time t. So I got to find the derivative of v. Equals a. Okay, and I'm just going to write down my velocity equation to help me remember. So my velocity was 6x squared minus 14x plus 4. So we'll take the derivative, and that will give me 12x minus 14. Okay, and then they want me to evaluate at 1 second. So again, let's practice doing that in our calculators. Right, so here I put my velocity equation in for y2. Okay, and so we'll do the exact same thing. So if I go to alpha window and go to the third option, I'm taking derivative with respect to x. This time I'm selecting y2. I'm evaluating at 1. All right, and I get -2, so that means my acceleration at 1 second is -2. That'd be meters per second squared. All right, and then the next two questions are pretty important. The first one asked me to find the displacement, and then the second asked me to find the total distance, and those are two very, very different things. Okay, so I'm going to use my calculator to calculate these values. So first, it's asking me displacement. Displacement is the distance between my start and my end. Okay, so all I would need to do is figure out what my position, what my position at the first time is. So in this case, 0. Right, so my initial position was 5. And then my ending position was 1.396. So my displacement is just the difference between these two values. So all I would need to do is, for instance, s of 1.7 minus s of 0. Okay, so in this case, that'd be 1.396 minus 5. All right, and I get negative 3.604. All right, so that essentially means that in the span of 1.7 seconds, I ended up going backwards 3.604, which is fine. Okay, so the next question asked me to find the total distance traveled between 0 and 1.7 seconds. This is very different from displacement. With displacement, the sign doesn't really matter. You just kind of get what you get. You only care about the beginning and the end. With distance traveled, you do have to worry about the sign. And so because of that, I need to find my critical numbers. Hey, basically, if you're traveling forward and then you're traveling backwards, your total displacement is just going to be like from here to here. Okay, so your starting point and then your ending point. But if you want to find how much distance you actually traveled, you need to take all of this into account. And so your negatives, you essentially need to turn into positives. You can sort of think about it like the absolute value of your position over time. Hey, everything needs to be positive. So I need to figure out when my function changes sign. Okay, so in order to do that, I need to find my critical numbers. And we already did that. I know that there's a critical number at 1/3. Okay, we did that earlier. And so second step is going to do a candidates test. Yes, this is coming back. Okay, so I put my endpoints in and then also my critical number. All right, and I need to evaluate my function at these points. And luckily, we already did that for some of these. So 5, 1.396. And then I just need to evaluate at 1/3. Okay, and I get 5.629. And so as you can see, between 0 and 1/3, we traveled forward. And then from 1/3 to 1.7, we traveled backwards. Okay, and that distance is really important. So what I need to do is figure out how far I traveled between my starting and my middle here. So I traveled 0.629. And then between here, I have to figure out how much I traveled, so I'm going to use my calculator for that. Okay, so it's going to be minus 1.396. All right, and so I find that I traveled a distance of 4.233. Okay, and so I got to add these values together. Okay, and I find that my total distance traveled is 4.862 meters. Okay, let's move on. All Alright, so last part, it's asking me when the particle is speeding up and when it's slowing down. And this is something that's pretty common. So when your particle is speeding up, that means your velocity and acceleration have the same sign. So that means that if your velocity is positive and your acceleration is positive, you're going faster in the positive direction. If they're both negative, you're going faster in the negative direction, but you still are speeding up. A slowing down means your velocity and acceleration have opposite signs, so you'd be like going in the positive direction, but at a decreasing rate, for instance, or going in the negative direction with an increasing rate, which really means that you're starting to go positive. Okay, so in order to do that, what we need to do is do a double sign chart, and we need to figure out the signs of my velocity and of my acceleration. Okay, so luckily they already did a lot of the work for us, so I just need to find my critical numbers and I need to find my potential inflection points. Okay, so here I know that I have critical numbers at 1/3 and 2, and here I'll have an inflection point at 7/6. Okay, so what I need to do is put all of these values into my number line. Okay, so I have a value, a critical number at 1/3, and then maybe an inflection point at 7/6, and then a critical point at 2. Okay, and we already tested these for my critical numbers at least. So if I plug in a number smaller than 1/3, I end up with a positive number. And then between 1/3 and 2, if I plug a number in, it'll be negative. So if I plug like 1 in, so it'll be negative. And then if I plug in a number greater than 2, I'll get a positive number again. Okay, now let's test my acceleration. So if I plug a number smaller than 7/6 in, like 0, I'll get a negative number. So it's negative between both of these. I don't need to test 1/3 for my acceleration because 1/3 is a critical number, not an inflection point, and so it won't change. The acceleration won't change in between 1/3 and then over here. Okay, and then greater than 7/6, if I plug a number in, it will be positive. Okay, so from here I can draw some conclusions. Okay, I know first of all that I'm speeding up between, I'll say 1/3 and 7/6, and 2 to infinity. The reason being because my velocity and acceleration have the same sign. Okay, I know I'm slowing down on my other intervals, so between 0 and 1/3, and then 7/6 to 2, and I know that because my velocity and acceleration have opposite signs. Alright, that's my justification. That's it for these notes. I'll see y'all later.